Hello everyone, welcome to Aakruthi Art of Mathematics Simple Mathematics Classes. I am Sudhir MK. In this class, I am discussing competitive questions from probability and this is competitive class 3. Please subscribe this channel, also like and share this video. In this video class, I am discussing independent events and problems related to it. Now first we say definition of independent events. The occurrence of one event does not dependent on the other, then it is called as independent events. Now, how to identify two events are independent? So if A and B are two mutually independent events, then P of A intersection B is equal to P of A into P of B. So for two events A and B, so they are mutually independent means we can write P of A intersection B is P of A into P of B. So next we discuss some problems. So this is problem number 45. If A and B are independent events such that P of A is greater than 0 and less than 1 and P of B is also greater than 0 and less than 1, then which of the following is not correct? You have to identify which of the following is not correct. So here first option, that is A and B are mutually exclusive. So here it is given A and B are independent and A and B are mutually exclusive may not be true. And A and B dash are independent, it is always true. And A dash and B are independent, it is also true. And A dash and B dash are independent, it is also true. That is, if A and B are independent, then A and B dash is also independent. A dash B is also independent, and A dash B dash is also independent. So therefore, here not correct option is option A. So option A is not correct. So next question, question number 46. If two events are independent, then so option A is they must be mutually exclusive or the sum of their probabilities must be equal to 1. Option C is A and B both are correct and option D is none of the above is correct. So here option A is they must be mutually exclusive. So this may not be true. The sum of their probabilities must be equal to 1. So this is also may not be true. So that is P of A plus P of B. So equal to 1. This is also may not be true. And option A and B both are correct. So this is also wrong. So therefore here none of the above is correct. So it is option D. So here none of the above is correct. So next it is question number 47 and this is from CET 2017. Two events A and B will be independent if you have to check which of the following option is correct. So here it is given A and B are independent. So then A dash and B dash is also independent. So therefore we can write P of A dash intersection B dash as P of A dash into P of B dash. And P of A dash is same as 1 minus P of A and P of B dash is same as 1 minus P of B. So therefore when A and B are independent, we can write P of A dash intersection B dash as 1 minus P of A into P of B. So therefore correct option is option A. And all other options are wrong. It is P of A plus P of B equal to 1. It is wrong. And P of A equal to P of B also wrong. And A and B are mutually exclusive. This is also wrong. So therefore correct option is P of A dash intersection B dash is 1 minus P of A into 1 minus P of B. So next question, question number 48. If A and B are two independent events with P of A is 3 by 5 and P of B is 4 by 9. And you have to find P of A dash intersection B dash. So here it is given A and B are independent events. So then A dash and B dash is also independent events. So therefore directly we can write P of A dash intersection B dash as P of A dash into P of B dash. And P of A dash is 1 minus P of A and P of B dash is 1 minus P of B. So we substitute all these values. P of A is 3 by 5 and P of B is 4 by 9. So we get 1 minus 3 by 5 into 1 minus 4 by 9. And 1 minus 3 by 5 is 2 by 5. And 1 minus 4 by 9 is 5 by 9. So answer is 2 by 9. So here 5 get cancelled. So remaining is 2 by 9 which is option D. So here correct option is option D. So next question, question number 49. If P of B is 3 by 5 and P of A bar B is 1 by 2, that is probability of A, given P is 1 by 2 and P of A union B is 4 by 5, then what is P of A union B dash plus P of A dash union B? So here you have to find P of A union B dash plus P of A dash union B. Now here conditional probability is given. So first we find P of A intersection B. So using formula P of A bar B into P of B. So it is P of A intersection B is P of A given B into P of B. And here P of A bar B is 1 by 2 and P of B is 3 by 5. So we get 3 divided by 10. So therefore P of A intersection B is 3 divided by 10. So now first we calculate P of A. So using P of A union B formula, P of A union B is P of A plus P of B minus P of A intersection B. So therefore P of A is P of A union B plus P of A intersection B minus P of B. So P of A union B is given, it is 4 by 5 and P of A intersection B is 3 by 10 and P of B is 3 by 5. So when we substitute and calculate, we get P of A is 5 by 10, which is same as 1 by 2. So take 10 LCM. So we get P of A is 1 by 2. Now here P of A in section B. So P of A in section B is 3 by 10, and which is same as P of A into P of B. That is 3 by 5 into 1 by 2. It is also 3 by 10. Therefore A and B are independent events. So A and B are independent events. So now we have to calculate P of A dash union B. So it is same as P of A dash plus P of B minus P of A dash intersection B. Since A and B are independent, so directly we can write it as P of A dash into P of B. If A and B are independent, A dash and B is also independent. So therefore we can write P of A dash intersection B as P of A dash into P of B. So substitute all these values, and here it is P of A is 1 by 2 and P of A dash is also 1 by 2. It is 1 minus 1 by 2, which is also 1 by 2. So therefore P of A dash is 1 by 2 and P of B is 3 by 5 minus 1 by 2 into 3 by 5. So we get 8 by 10, which is same as 4 by 5. That is P of A dash union B is 4 by 5. So then again you have to calculate P of A union B whole dash plus P of A dash union B. So we have to add P of A union B dash and P of A dash union B. Now P of A union B whole dash is 1 minus P of A union B. So it is P of A union B whole dash is 1 minus P of A union B. It is 1 minus 4 by 5, and P of A dash union B already calculated. It is 4 by 5. So we get 1 minus 4 by 5 plus 4 by 5. So here 4 by 5 cancel. So remaining is 1. Therefore P of A union B dash plus P of A dash union B is 1. So which is option D. So here correct option is option D. So next question, question number 50. Two events E and F are independent. P of A is 0.3 and P of E union F is 0.5. So then P of E bar F minus P of F bar E. So here we have to calculate probability of E given F minus probability of F given E. Now here it is given P of A is 0.3 and P of E union F is 0.5. Using this we calculate P of F. So we have formula P of E union F is P of A plus P of F minus P of E intersection F. Since E and F are independent, so we can write it as P of E into P of F. Now substitute all these values. P of E union F is 0.5 and P of A is 0.3, and here we can take P of F as common. So we get P of F common outside. So then we get 1 minus P of A. So it is 1 minus 0.3. So taking P of F common. So then take 0.3 to other side. So we get 0.5 minus 0.3, which is 0.2. And here 1 minus 0.3 is 0.7. And we take 0.7 to other side. So we get 0.2 divided by 0.7, which is 2 by 7. So therefore here P of F is 2 by 7. So then we calculate P of E bar F minus P of F bar E. Using formula we can write it as P of E intersection F divided by P of F minus P of E intersection F divided by P of E. And since E and F are independent, we can write P of E intersection F as P of E into P of F. So therefore here P of F cancel. So same type P of E intersection F is P of E into P of F. And here also P of E get cancelled. So remaining is P of E minus P of F. And P of E value is given. It is 0.3. So 0.3 can be written as 3 by 10 minus P of F. It is 2 by 7. So it is 3 by 10 minus 2 by 7. So here 70 is LCM. So we get 7 3s are 21 minus 20, which is 1 by 70. So which is option C. So here correct option is option C. So next question, question number 51, and it is from CET 2014. If the events A and B are independent and P of A dash equal to 2 by 3 and P of B dash is 2 by 7, then what is P of A intersection B? So here A and B are independent. So therefore P of A intersection B directly we can write it as P of A into P of B. And P of A is always equal to 1 minus P of A dash, and P of B always equal to 1 minus P of B dash. So we substitute all these values. So it is 1 minus P of A dash, it is 2 by 3, and P of B dash is 2 by 7. So we get 1 minus 2 by 3 into 1 minus 2 by 7. So which is 1 by 3 into 5 by 7. So which is 5 by 21. So which is option B. So here correct option is option B, which is 5 by 21. So next question, question number 52, and it is from CET 2020. If A and B are two events such that P of A is 1 by 3 and P of B is 1 by 2 and P of A intersection B is 1 by 6, then what is P of A dash bar B? So that is P of A dash given B. So here it is given P of A is 1 by 3 and P of B is 1 by 2 and P of A intersection B is 1 by 6, and here P of A into P of B is P of A intersection B. So therefore A and B are independent. So here A and B are independent since P of A into P of B is P of A intersection B. So then we calculate P of A dash given B. So it is P of A dash given B is P of A dash intersection B divided by P of B. Since A and B are independent, A dash and B also independent. So therefore we can write P of A dash into P of B divided by P of B. and here P of B cancel, we get P of A dash, so which is equal to 1 minus P of A. It is 1 minus 1 by 3, which is 2 by 3, so which is option D. So here correct option is option D. So next it is Bayes theorem. If the events E1, E2, E3, etc. up to En are mutually exclusive and exhaustive events, and A is any event with P of A greater than 0, so then we have to find P of E1 given A. It is P of E1 given A is P of E1 into P of A given E1 divided by summation of P of Ej into P of A given Ej. So that is P of E1 bar A can be written as P of E1 into P of A bar E1 divided by summation of P of Ej into P of A bar Ej. So it is summation means you have to write the addition. So next we discuss some problems. It is problem number 53. In a car manufacturing factory, unit X and Y produces 70% and 30% cars respectively. 80% from the unit X and 90% from the unit Y are rated standard quality. A car is chosen randomly and it is found to be standard quality. The probability that it has come from the unit X is. So here it is given car is manufactured in two units X and Y. So it is car manufactured in the unit X is 70% and car manufactured in the unit Y is 30%. So therefore we take E1 as car from unit X and E2 is car from unit Y. So therefore here P of E1, that is probability that car is produced from unit X is 70 by 100, which is same as 7 by 10. And P of E2, it is 30 by 100, it is 3 by 10. So P of E1 is 7 by 10 and P of E2 is 3 by 10. We take A as car of the standard quality. So we take A as car of the standard quality. So then P of A bar E1. So P of A bar E1 is 8 by 10. That is car is produced from unit X and it is of standard quality. So here it is given 80% from unit X are standard quality. So therefore it is 8 by 100, which is same as 8 by 10. And P of A bar E2, that is car produced from the unit Y and it is of standard quality. It is 90 by 100, which is same as 9 by 10. So here P of A bar E1 is 8 by 10 and P of A bar E2 is 9 by 10, and we have to calculate P of E1 bar A. That is already one standard car is selected. We have to find the probability that selected car is from unit X. So it is P of E1 bar A. That is already a standard car is selected and we have to find the probability that it is from unit X. That is P of E1 bar A. So P of E1 bar A is P of E1 into P of A bar E1 divided by P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. So we substitute all these values. So P of E1 is 7 by 10 and P of A bar E1 is 8 by 10. So divided by 7 by 10 into 8 by 10 plus P of E2 is 3 by 10 into 9 by 10. So here substitute all these values, and here denominator is 10 into 10 100. So we can cancel 100. So remaining is 7 into 8 56, and here 7 into 8 is 56 plus 3 into 9 is 27. So we get 56 by 56 plus 27, which is 56 by 83. So which is option B. So here correct option is option B, which is 56 by 83. So next question number 54, and it is from CET 2020. Events E1 and E2 from a sample space S. A is any event such that P of E1 equal to P of E2 equal to 1 by 2 and P of E2 bar A is 1 by 2 and P of A bar E2 is 2 by 3. So then we have to calculate P of E1 bar A. So here it is given that E1 and E2 are partitions of a sample space S. That is E1 union E2 is always equal to S. So here P of E2 bar A and P of A bar E2 is given, and we have to calculate P of E1 bar A. So here directly also we can calculate like this. It is P of E1 union P of E2 bar A can be written as P of E1 bar A plus P of E2 bar A. So it is P of E1 union P of E2 bar A can be written as P of E1 bar A plus P of E2 bar A, which is same as P of S bar A, which is equal to 1. So therefore P of E1 bar A. So here P of E1 bar A is 1 minus P of E2 bar A. So which is same as 1 minus 1 by 2, which is 1 by 2. So which is option D. So here correct option is option D. Since E1 and E2 are two partition of S, so we get P of E1 bar A is 1 minus P of E2 bar A. So it is 1 by 2. So or else we use formula. So here P of E2 bar A is P of E2 into P of A bar E2 divided by P of E1 P of A bar E1 plus P of E2 into P of A bar E2. Since here P of E1 and P of E2 are same, so we can cancel it. So remaining is P of A1 bar E divided by P of A bar E1 plus P of A bar E2. So substitute all these values. So we get 1 by 2 equal to 2 by 3 divided by P of A bar E1 plus 2 by 3. When we take this denominator to other side and half to this side, so we get P of A bar E1 plus 2 by 3 equal to 2 by 3 divided by 1 by 2. So which is 4 by 3. So therefore P of A bar E1 plus 2 by 3 is 4 by 3, and we have to calculate P of A bar E1 value. So it is 4 by 3 minus 2 by 3 equal to 2 by 3. So therefore P of A bar E1 is 2 by 3. So then we calculate P of E1 bar A. So question is to find P of E1 bar A. So therefore P of E1 bar A equal to P of E1 into P of A bar E1 divided by P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. So we substitute all these values, and here also P of E1 and P of E2 are same. So we can cancel this. Remaining is P of A bar E1, which is 2 by 3 divided by P of A bar E1. It is 2 by 3 plus P of A bar E2. It is also 2 by 3. So we get 2 by 3 divided by 2 times of 2 by 3, and here 2 by 3 cancel. Remaining is 1 by 2. So therefore here correct option is option D. So which is equal to 1 by 2. So next question number 55, and this is from CET 2019. A man speaks truth 2 out of 3 times. He picks one natural number in the set S equal to 1, 2, 3, 4, 5, 6, 7, and he reports that it is even. The probability that it is actually even is. Here his report may be true or false. Here we have to find the probability that it is actually even number. That is, his report is true only. So we take even, that is getting even number. So therefore P of even is 3 by 7. So here we have 2, 4, 6, 3 even numbers out of 7. So therefore probability of getting even number is 3 by 7. And E2 getting odd number. So here we have 4 odd numbers. So therefore its probability P of E2 is 4 by 7. And we take A. A is man reports it is even number. So then P of A bar even, that is, it is actually even number, and he is also reporting even number. That is, when it is actually even and man reports it is even, it is 2 by 3. That is, he is telling truth. It is 2 out of 3. So it is 2 by 3. So then P of A bar E2, that is, when it is not an even number, but man report it is even number. That is, he is telling lies. It is 1 by 3. So man telling lies, it is 1 by 3. So then P of E bar A1. So that is, we have to find the probability that man is reporting it is even number and it is actually a even number. It is P of E1 bar A. So it is equal to P of E1 into P of A bar E1 divided by P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. So we substitute all these values. So we get 3 by 7 into 2 by 3 divided by 3 by 7 into 2 by 3 plus 4 by 7 into 1 by 3. So it is 3 by 5. Simplify this. So we get 3 by 5. So which is option C. So here correct option is option C. So next question number 56. A and B are two students. Their chance of solving a problem correctly are 1 by 3 and 1 by 4 respectively. If the probability of their making a common error is 1 by 20 and they obtain the same answer, then the probability of their answer to be correct is. So here chance of solving problem is 1 by 3 and 1 by 4 and their making common error is 1 by 20. So here we have to find they are obtaining same answer when answer is correct. So here we have to find the probability that they are obtaining same answer and answer also correct. So here we take P of E1, that is problem is solved by both. So that is problem is solved. It is 1 by 3 into 1 by 4. It is 1 by 12. And we take P of E2, problem is not solved. That is P of A dash into P of B dash. It is complement of 1 by 3 is 2 by 3 and complement of 1 by 4 is 3 by 4. So we get 2 by 3 into 3 by 4. It is 1 by 2. So here 3 get cancelled. 2 by 4 is 1 by 2. That is probability of problem is solved is 1 by 12 and probability that problem is not solved is 1 by 2. So let A, that is both obtain the same answer. So here we have two chances, that is both answer may be correct or they may mistake, in which also they will get same answer. So now here it is P of A bar E1, that is answer is correct and also they are getting same answer. If answer is correct, answer is same. So therefore its probability is 1. So that is both obtain the same answer when problem is solved. That is they have to get same answer and we have only one correct answer. So therefore both will get same answer when problem is solved. So its probability is 1 by 1, which is 1. So then P of A bar E2, that is problem is not solved, but they are getting same answer. So here it is given they are making common error is 1 by 20. If they are not solved, but they are getting common answer is 1 by 20. It is both obtain the same answer when problem is not solved is 1 by 20. So we have to find probability that both obtain the same answer when the problem is solved. So here already it is given that both obtain the same answer and we have to find the probability when answer is also correct. It is P of E1 bar A. It is P of E1 into P of A bar E1 divided by P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. So we substitute all these values. So we have P of E1 is 1 by 12 and P of A bar E1 is 1 divided by 1 by 12 into 1 plus 1 by 2 into 1 by 20. P of E2 is 1 by 2 and P of A bar E2 is 1 by 20. So we get 1 by 12 divided by 1 by 12 plus 1 by 2 into 1 by 20. When we simplify this, we get 10 by 13. So we take here LCM. So here we have denominator 12 and 40. LCM of 12 and 40 is 120. So when we take LCM 120 and simplify, we get 10 by 13. So which is option D. So here correct option is option D, which is 10 by 13. So that's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel Aakruthi Mathematics Classes. Thank you once again.